Thank you. So I think we already have a quick introduction of ourselves, right? And I thank everyone here for joining to know more about serverless on AWS. In today's agenda, we are going to go through what is serverless and what is event-driven architecture, and we'll see some of the use cases with the the architecture patterns that we discuss. And at the final stage, we'll have a small demo as Rohit discussed, and it's going to be a 200 level session. There will be no deep dive, but please feel free to unmute yourself and ask questions of any level, right? So before we jump on to our next slide, I would like to ask you, could anyone tell me what is serverless? What is serverless architecture or serverless application? Are you aware of what is serverless? Any one liner would be good to go. Please unmute yourself and tell your thoughts on what is serverless. And let's be interactive, right? That way, we exchange a lot of knowledge. Okay. Maybe I'll take that as no, and I will tell you more about what is serverless, right? So serverless is basically having your application, but you don't worry about the servers, right? Basically, you shift your management of underlying compute resources to us, to AWS, and we take advantage of all the scale, the economies of scale, and whatever that we have been innovating to run the workload more efficiently. With that we run and maintain your we help you to run your application based on the servers that we provide you, based on all the physical infrastructure in terms of compute, storage, database, and even the messaging and orchestration, which is a really important factor in serverless. We take care of all these factors, and customers focus more on the business logic and their APIs, right? This is what we obsess about all the time. So we give your developers or your team to focus more on your business logic, and the engineering team in AWS, we do this job of maintaining servers and managing the infrastructure for you, right? This is serverless. So we take care of all the servers and underlying infrastructure, and then we allow you to run your applications without worrying about the scale factor or the security and all such factors, right? This way you also benefit with the pay-as-you-go model, so you don't have to worry on spending more about the capital expenses, but it's going to be turning towards as a variable expenses. And there are many more advantages of using serverless. We'll touch upon that later in the slide, right? So why serverless? So because it makes your job easier, right? So you can automatically scale up and down with demand. So if you don't have serverless architecture, you must be spending a lot of your time allocating how the traffic is coming in. Should I increase my server, or should I increase the CPU capacity of my server? All these things, right? And I think the operational team would be spending a lot of their time on all of these daily operations. But at AWS, we take care of this core operations, and we allow you to focus more on the business, right? And you can leverage more built-in reliability and security. So at AWS, we know we have, for more than a decade, we had an experience at building Amazon.com, and then we brought up this AWS into picture, right? So we know how the security works and how reliable the system should be. So this is something that we provide to our customers, and they can easily make use of it by going serverless, and they can reduce the cost. As I said already, it's a pay-as-you-go usage model, and it's very easy to use, right? These are some of the benefits on why you should consider going serverless. Yeah. What are customers building with serverless, right? There are many use cases, and some of it are here. So they often start with IT automation. That's the first one, right? The first one, IT automation, that is, for example, using Lambda function to validate some of the configurations when you launch an EC2 instance. I hope you are at least aware of 100 level concepts in AWS, and you know what is EC2 and all Lambda functions and all that. But I'll touch upon serverless concepts again later in the slide, right? So these are some of the initial things that often IT companies start with, right? And next, some of the individual teams may start using Lambda integration with S3, the simple storage service that we have at AWS, with whether it is a Kinesis stream or some of the data processing application, to build some of the application that is related to data processing, right? And then as the experience goes further, you can focus more on building a web application altogether, right? By using whole microservice based applications, and then you can deploy the whole web application serverless way. And Rohit is also going to demonstrate how you can build a web application in serverless way. So that would be an interesting one. And at last, I think the advanced users would go for machine learning. Here also we use Lambda and many other services, and machine learning itself has some of the serverless features like Bedrock and all, but that's not the concept for today, right? So these are some of the use cases, or some of the areas where customers are looking for serverless, right? So this is how the serverless spectrum look like. So we have wide range of purpose-built serverless services. This is not limited to what you see on the screen right now. We have right from compute, storage to, if you want to define a workflow and you want to go, analyze streaming applications, and these things you can rapidly integrate with many other serverless applications and even third parties, right? This accelerate your time to production, right? So as you see on the screen, we have some primitive AWS services such as AWS Lambda, Fargate for containers. If you have container application in a serverless way, if you want to run S3, EFS, SQS, and many more. And some of the peripherals like services that related to database analytics workflow, you see Aurora serverless, DynamoDB, these all operate in a serverless way. So to start with, I suggest you to start with Lambda and EDA. If you have some application which you want to build newly, think of building the application in an event-driven architecture, right? So if let's say if you have some legacy application, I think Fargate is the way where you can bring in your legacy application on the containers and run it, right? In a serverless way again, right? So serverless suits for both of the case. If you want to build a new application altogether, or if you want to bring in some legacy application, so it suits to both of your requirements, right? Okay, so one thing that is common across serverless application is that they follow the idea of internet and the web. Basically having small pieces which are loosely joined, and each of the pieces that you see, right? So for example, in the left hand side you see Lambda, S3, step function, API gateway, DynamoDB, and many more, right? Event bridge and all that. So these are some of the services, and we take the services and make it loosely coupled to build your application. So here, right here, we have we often start with APIs, that where APIs are managed by API gateway. So we have these API endpoints which are coming from the front end app, right? And then we have each of the services are very modular. They perform their own tasks. So it's not like it's very complex legacy application, right? So it is microservice architecture, you can say, and it's a event-driven architecture as well. So what I meant is they operate in a modular fashion, right? It often starts with API and those are managed by API gateway as the application front door, right? Often events. So this API endpoints may start with API, but often it turns it as an event or the message that further communicates with all of the other services, right, in the back end. So this is how event-driven architecture in a serverless word looks like, right? So you have some endpoint, you initialize the app, you configure the table, but these configuration, after that may go with uploader, but it will not collide with the functionality of other services, right? That is what I meant here. So let's look at AWS Lambda. It's one of the very important service that we have at AWS. So what is Lambda? Lambda is basically an event-driven function as a service. So if a function, for example, right, a function is basically the unit of Lambda service. I will tell you how Lambda look like. I hope you are aware of Lambda. Could anyone tell if you have already worked on Lambda before, or if you are new to it? Could you unmute yourself and tell us whether you are how much comfortable with Lambda? Anyone can volunteer here and just unmute yourself and say how you're comfortable with Lambda, right? Yeah.
Tejasvi, we have Sandhi who is saying that he used it before.
Okay. That's thanks, Sanket, for reading the message. Sorry, I cannot read the message since I'm presenting, but thank you for that. So if you have used Lambda already, you know that there is a function, a function is basically the unit of Lambda service, and any function that you invoke, that you run is called the invocation, right? For example, when you want to run a function, it definitely needs an invocation. And a function invocation basically has some event. Based on the event, you are going to invoke the function and execute your Lambda, right? That is all about it. So here in the serverless architecture, here it says there is some event source, whether the source is coming from any data change, this state, data state changes, or maybe any request to endpoints, whether it is a HTTP endpoint or API trigger, right? Or maybe changes in the resource state, data state or the resource state. So you can think of any real world example and you can try to fit in Lambda here. So it only needs an event source where the event or the message will be captured by the function and it executes as an invocation, it executes, right? So here Lambda function supports all these languages that you see here, but it's not limited to the runtime that you provide. You can also if you have your own any other language that you see here, you can create a runtime environment for it and execute Lambda, right? So this Lambda service also integrates with many other AWS services, right? So it can easily integrate. If there is a state in data change, you want Lambda to do some operation on the S3 bucket, so you can uh, bring in those custom logic here and execute it, right? That's what I meant.
Just to add on to that, so basically events could be different for different landscape. Like for an e-commerce application, right? Adding any item in a cart could be event for you, right? And for like let's say financial application, any transactions could be event for you, right? And based on that, you invoke your Lambda, which works in the backend to get your things done, and returns the response to the user.
Yeah. So this is what he meant. The landscape could change, whether it is API request or data state changes or anything like that. So you can definitely go integrate with Lambda.
Tejashri, sorry to interrupt. So we have another question in the chat. So Mr. Khandokar Bhai wants to know that does it support only these languages or like there is some other languages it can support?
Yeah, it supports other languages also. Like I said, you can zip the runtime. If there are any other language that is not supported, you can create your own runtime environment. You can bring in your own as well. So we can share AWS doc. So Rohit, could you share the doc on how they can zip and upload it to create the runtime environment, custom runtime environment?
Yeah. Okay. We can share the blog saying how they can customize the runtime environment for the additional code requirements. But yeah,
Right.
you get multiple languages out of the box in the Lambda, like Java, Go, PowerShell, Node.js, then Python, Ruby, all those.
Right.
I hope, Bhaiya, that answers your queries. Thank you.
Yeah. So the simple answer is yes, you can bring in any other languages, not limited to the language that you see here. Yeah. And let's jump on to anatomy of Lambda function. So we were talking about the function, events, and all that. So function is a unit of Lambda service, right? So this is a function. So you see def handler. This is the entry point to your business logic, and we have something called event that is written, defined here. So this contains the details of what triggered the Lambda. So maybe Lambda can be triggered by API gateway. So it contains details about that particular event, and context has additional information about the event and the execution, right? So this is the anatomy of Lambda. Okay. And some of the configuration features that I have put down here. So when you say you want to create a Lambda function, definitely you want some CPU and network allocated to it, right? So you will say I have a very big execution, the logic that needs to be executed. How do I set up memory? So you can select memory between 128 MB to 10 GB in the increments of 1 MB, right? And memory is the only knob here. So CPU is proportional to the memory that you allocate. So there is a profiling function with Lambda power tuning. So using Lambda power tuning, you can also see which one is optimal for your function. So power tuning is this Lambda power tuning is basically an open source tool which can help you to visualize and also fine tune the memory and power configuration for your Lambda function. This way you know which one is better, which level of memory is better for you, right? And there is another aspect where you can only run a function for 15 minutes only, so you cannot increase that. So if you have any business logic, you need to think that Lambda is suited to run only for up to 15 minutes, because it is designed to work in a serverless way, right? And it needs faster execution. That's how in event driven architecture things would happen. So this is the execution time that you have. And in terms of security, we have execution role. This controls who Lambda can talk to, right? For example, you want to execute something, Lambda wants to write to DynamoDB. So we go and select the execution role for DynamoDB, and then Lambda is allotted. It is given permission to execute on other services, right? And there is something called resource policy. So this controls who can invoke the Lambda. So as I said, so it's about the resource-based policy, right? Where who can invoke Lambda. So as whether API gateway is trying to invoke Lambda, then definitely it should have resource policies as well, right? That's one of the security feature. And yeah, in terms of pricing, Lambda is has very granular level. It is 1 millisecond billing granularity. So basically, if you are running for, let's say, 7 milliseconds, you are costed for only 7 milliseconds, not more than that. We are not rounding up to other duration, nearest duration, right? So this way the cost is also very less, and on top of it, it also has some free tiers. So sorry, my voice is going. Could you please go on mute? Yeah. So in terms of pricing, Lambda is also very cheap, right? You can also utilize the free tier that we have at Lambda service. So Lambda also integrates with CloudWatch out of the box. So any parameters that you want to analyze, or you want to build some custom metrics, so we already have CloudWatch integrated. You can go and analyze how your Lambda is performing, how many invocations there has been happened, and all that, right? So this is a snapshot of how the monitoring would look like. So let's switch on to serverless architecture pattern, how you want to design or architect your serverless application, right? So before we jump on, I just want to highlight here what is event. Event is something that happens particularly one of importance, right? You can think of it as a, in simple terms, you can think of it as a signal that a system state has changed in your application, right? So event may be a change in the state, or an order was placed on your website. You can think that as a event, right? Lambda supports, there are three different types of invocation, whether it is synchronous, asynchronous, or pole based invocation. Also, if let's say a Lambda function to process some of the clicks in your mobile application, or checking for some of the state on whether it is successful or not, these are these are example of asynchronous application, right? Yeah, and synchronous, I think we'll go touch upon how the synchronous use case would look like, and the asynchronous and also pole based would look like. So here I just wanted to let you know what is an event, right? You just think of it as a simple, in a simple terms, it's a system state has changed. Then we take that as an event, right? So even in the API driven architecture, so as the picture depicts, so your system has a put event, right? Put HTTP call that has been given through the API gateway. Since this is a synchronous processing, we expect the response to be under 30 seconds when you involve API gateway, because that's the timeout that you have. But you can definitely go and change this timeout configuration. But the whole point is, you give some HTTP call invoke, and API gateway forwards it to Lambda, and it does some operation, and this expects the response immediately, right? And then we return the success status to our client. So this is the API driven architecture, right? So here you see the API, here you see that the customer, the client has been waiting for the response. It is expecting the request to process and then give the response, right? So in this case, the client has to see when we send some request and the processing of the request is happening, definitely there could be a lot of errors, and in that case, client should implement those error handling and even the retry logics, right? If they want to retry. But let's see how this will be taken care with event-driven architecture, right? So event-driven architecture is going to be like asynchronous processing. So the client sends the request in a certain format, that is, for example, a JSON that you see here. The payload is a JSON, and we have event bridge. Event bridge is a very nice and interesting serverless service that we have at AWS. So let's take that event bridge is taking this event, and it immediately sends the response saying that, okay, the request has been received. It's not saying that the request has been processed, but the request has been received. And event bridge has a mechanism to store all this request in an archive way also, and it has a built-in error handling and retry logic. So by default, to be specific, event bridge retries for example, there is an event, it retries for 24 hours and for up to 185 times with some logic like exponential backoff and randomized delay. So these are some of the features that you get benefited by using serverless feature, right? So and it sends the response, but here the client has to handle what happened to my request, or they should bring in some other mechanism to see if the request has been processed or failed, what's the status and all that. But the request will take place here, right? The processing will take place. It invokes and updates the items and returns back to event bridge, and then further you have to poll the results, or look for the results. So this way it is very highly resilient, because we are storing all the requests that are coming in the event bridge, right? And highly durable also. And as I already said, it has retries, and these retries are also configurable depending on your use cases, right? So that's about it. Okay, so events, so in a decoupled architecture, right? So each component or service, they operate and execute independently of the other, right? Based on events. The communication that we send is via some specific interfaces, right? So these are defined and differently. The interface is defined differently in API, that is event-driven architecture, right? So events is nothing but all the status, the change in the state that happens in this decoupled architecture, right? That's what I meant to say here. So let's see the trends of event-driven architecture. So loose coupling is is what we look for in the serverless architecture when you want to design an application. So this allows your team to build and deploy your application more independently, and it should be loosely coupled for maximum benefits, right? That's how you increase your speed and agility. Um, and there is resiliency. So let's say in legacy application, when you build an application which is, let's say the upstream is giving the event or some request to downstream, and there is a failure at the downstream, and further downstream will result in cascading failures. But here in event-driven architecture, the cascading failures go away with event-driven architecture, right? So you are reducing the radius of failures and increasing the resiliency by implementing EDA. And scalability. So with loose coupling and asynchronous process comes more with ability to go quickly and scale on demand. So these are some of the trends with event-driven architecture, right? So let's see what are the components in EDA. When I say EDA, it's an event-driven architecture. So the components are producers. As I say, as the name itself says, these are some of the publishers where they publish some event, right? And there are some consumer. The publisher want to publish the message to the consumers, right? And in between we have a event broker, right? So this is a meeting place between the producer and the consumer. So the broker is how events are exchanged. So these are the components when you think of EDA. So event brokers, right? The middle part that you saw here, right? What are the mechanism of message, processing, right? So there could be pull based and push based. So when we say pull, right, the responsibility is delegated to the subscriber. So there are publishers and there are subscribers, right? But the subscribers or the consumers should pull the message. So this way more ownership comes with more overhead, right? So they have to take care of retries, read location, etc. And this is very useful with container based application, right? And we have something called push based. Here there is few responsibility for the subscribers because the routers takes care of pushing the message and also taking care of owning the delivery and retrying, right? So as I said, Event Bridge is one of such service which takes care of delivery and retries, and these are simple for your usage because they are AWS Managed Services. So SNS is also a push based, whether you want to push a notification to app or whether app to a customer mobile notification, so you go for SNS. So some of the example of queues in pull based are SQS and MQ, and streams are Kinesis and Kafka services, right? For the streams pull based applications. So again, I'll ask you to, stop me at any point and ask any of the questions that you may have, right? So, yeah. So EDA on AWS, right? So we can take a look at the 4 different services that are available in AWS. This helps you with building the asynchronous processing of events, right? So we have SQS here. The SQS is a fully managed messaging queue service. This also enables you to decouple and scale the microservices and distributed systems and in the serverless applications, right? And we have SNS. This is also a fully managed service for both system to system or whether it is app to person communication. It pushes the notifications. It's a push based service. So again, we have Event Bridge. So Amazon Event Bridge is again a serverless service, right? It has an event bus that makes it easy to connect your application together using data from your own applications, and also integrate with whether it's a SaaS application or AWS service altogether. So Amazon Event Bridge basically helps you with the choreography of orchestrating or sending the events to your other application, right? And we have step function. Step functions is again an orchestrator service. This makes it easy for you to sequence. Let's say you have one Lambda function triggering some other service and comes back, you want to pull the results and execute or trigger something else. So this series of workflow that you can orchestrate with Lambda function using step functions. So these are some of the services that you can see in EDA on AWS, which also helps with asynchronous processing of events in your applications, right? So let's see some of the use cases, whether it is API driven use case or EDA, event driven use cases. But let's see how the synchronous processing happens, right? APIs are the front door for your application in terms of RESTful microservices, right? They basically try to access the data, or they want to run some business logic in the backend. So using the API gateway, you can create these RESTful microservices, or whether it is a WebSocket API also. So it's a real-time two-way communication application, right? So we have API gateway. This translates the incoming HTTP request to every event payload. I mean, it has some schema where how that request has to be transformed to Lambda, right? And then Lambda reads this and writes the data to DynamoDB. This is just an example, of how the RESTful microservices would look like. So in this case, you are just enabling accessing logs and the logging metrics, right? So with AWS X-Ray helps with logging and tracing, and CloudWatch to build some embedded metric format, and also you can create custom metrics here. This is how you can increase your visibility into what's happening in the system, right? So there is another service called AppSync. It's AppSync is basically again a serverless service that we provide at AWS. It's a completely managed GraphQL and PubSub API service. So when I say GraphQL, it's an open source data query and manipulation language for your APIs, right? So what AppSync does, let's say there is some request that is coming in and you want to connect to multiple data source and get the data, the best, the suitable data for you. So AppSync enables your developers to connect to these applications and services to data and events with the secure and serverless, highly performing, by executing highly performing GraphQL, and PubSub APIs. So the one single API can have access directly to DynamoDB NoSQL table, or whether it, and also it can connect to Aurora OpenSearch and get the right data for your application for the requests that are coming in right from here. So this is one of the use case where you can see the example of API driven use case, right? Synchronous processing way. So let's see how the asynchronous processing use cases would look like, right? In terms of event driven use cases. So we have let's say we want to process the file uploads, whether it is resize photo or extract some text from a photo or translate. So we have this photo which is getting uploaded to S3 and asynchronous. So whenever there is upload or any update in the item, these items, the information about that item, that is bucket name and the object key, will passed on to the Lambda, and Lambda will further take care of the custom logic that you put in the Lambda, right? Whether it is resize or extract or anything. And further, you can also add some new functionalities by whether a Lambda triggering recognition, right, to recognize what is the picture is about, right, and also store all those metadata in DynamoDB table. So this is one of the use case of how the event-driven architecture or the synchronous way of file processing look like, right? Right. So I think in the previous slide we saw how we can add new functionality. Here I'm just saying you can combine these features in a step function altogether. The Lambda does some operation, let's say it does some translation or resizing photo, and also it sends the photo to recognition and gets the results, or it stores the results in DynamoDB. You can orchestrate all these together with the step function. So as the features gets on added, it might be confusing for you to how I'm reading the or polling the response. So you can go through this step function, which is again a service in AWS. So this way you can offload error handling, or if you want to implement retry logic and simplify the integration with any other AWS services, you can use step functions for such features that you want to have.
Just one point on the step functions. If we can just go back to the slide. So it's like, you can do multiple things in one Lambda, right? But it's not recommended or best practice to do so. So what we are trying to tell you here is, have multiple Lambdas in a go, because you'll have to do all the error handling. Like, let's say if you're sending image to recognition for recognizing objects, or, you are storing the data that came from recognition to DynamoDB, right? So you'll have to take care of a lot of error handling, right? Instead, what you could do is have multiple Lambdas. They'll be executed in stepwise manner, right? Once this activity is done, you can go to this. And in step functions, you can do error handling as well, right? That if this Lambda function is successful, go here. If this Lambda function is not successful, retry this job or go back to some other part down the lane, right? So it helps you, offload those error handling that you put in code to the service itself.
Right. Thanks for adding this, Rohit. So I hope this gave you more insight into how the event-driven use case would look like, right? So we can also think of streaming data ingestion. So streaming data is generally processed over a time window. For example, there is a clickstream analysis where you are analyzing how many let's say you have a website and you want to analyze the user behavior, that we call whether user would be interested in some advertisement, and you want to do some machine learning processing on top of it and suggest similar kind of items for them and all that. So these are called streaming data, which are processed over a time window, right? They are real-time workloads also. So, and also one more important is in streaming, the sequence of the events tend to be very important. So we use Kinesis for streaming data applications, right? So again, by using Lambda here, you can completely offload polling and tracking logic to the Lambda services, and you can focus mainly on your processing logic, how you want to process each of the stream and what kind of analysis you want to do, right? So the first step, as you see here, the Lambda service polls the Kinesis data stream. This is the Kinesis data stream for messages, and as a second step, you see here, the function is synchronously invoked with batches of messages. All the streams will be given to the Lambda, and further this Lambda takes care of how you want to process it or push the data to downstreams, and how you want to analyze it. So this is just an example of how you consume, process, and store the data for streaming data application. And that is again event-driven architecture, right? So there is one example of semi-serverless webhook. So webhooks are, they basically expose the RESTful interface to capture some data from your upstream, and then whether it could be third-party application. So basically you capture some data from your upstream, right? We have API gateway, and you captured some data and give those data to Kinesis data streams as a streaming service, and this batches the data and gives it to the Lambda function. And again, we have RDS to perform some transactions on these are the batches that Lambda sends, right? So you can think of it as a semi-serverless, but since RDS is involved, you can do the basically perform some transaction on each of the batches that Lambda sends, right? So fan out option, I think just wanted to highlight on how the fan out option is provided with the EDA, right? So let's say, what is fan out, right? So let's say you have multiple consumers who are interested in particular event, on the same particular event, right? So it generally refers as the process where a service or the message router delivers multiple consumers which are in parallel. So for example, here we have event bridge, which is delivering the message to multiple consumer, Lambda 1, Lambda 2, Lambda 3 for different kind of process, right? So this way, with event-driven architecture, it helps you with fan out as well. So as the picture itself says, we have API gateway, right? It does some custom authorizer with Lambda. You can do such custom authorizing logic, and the event is sent to event bridge. So in event bridge, we also store the event, right? I think I have mentioned, if you were keen on listening, I mentioned that event bridge also has some archival where it archives all of the events and retries on its own for certain extent, right? And if some of the messages fails, it sends it to DLQ, that is dead letter queue, for further later processing, or if you want to go debug what happened to this particular message, this will be present in different queue called dead letter queue. And the fan out option is available with event bridge. That is, let's say some status that let's say you ordered a placement for a cloth, right? The order has created, whether it has been processed or whether it has been refunded. So there could be many other streams when we look at an order, right? So this fan out, that is multiple consumers, so which are interested in particular event, the same event. So this helps with event driven architecture helps the fan out option as well. So let's see how the large scale data processing with the AWS step function would look like. So so definitely each of the AWS service has its own features and suited for particular use cases. So if you have large scale data processing, I think you should definitely go with a step function, right? I will say step function is an orchestrator where it orchestrates the workflow for you, right? You have parallel workloads, right? Let's say you have defined a map state, where a map where you have basically you're defining a workflow where you get the S3 location, you take the item from the S3, you extract the content and do some analysis, and again write the results back to S3. This is one logic, right? And which consumes one set of data. Let's say you want to execute this in parallel. So step function allows you with 10,000 parallel execution. So you can imagine how massively it can accommodate the scaling and processing of batches of data sets that you have, right? So one data set with let's say 10,000 items or 1,000 items, you give it to one step function, and again you run this in parallel for up to 10,000 executions, right? So that's the support that we I think that's pretty much I wanted to touch upon in terms of mass parallelization, right? Uh, right. So I think so far we discussed a lot of use cases, right? Whether it is a massive processing with the step function or the fan out options, how the semi-serverless webhook would look like, right? That you want to take some request from your third party application and do on top of it. And we also touched upon streaming data ingestion, right? Whether it is a clickstream data, how you can achieve this with event driven architecture, right? And also we touched upon the very simple use case such as processing file uploads and how you can further uh, add on new features of adding whether it is a recognition or personalize. There are many services that we have at AWS, so Lambda can integrate the services for your own features or the use cases, right? So I think these are some of the use cases that we touched so far. And uh, before we go on to the demo, right, Rohit is going to demo on a web application where he has used recognition, personalize, and many more with Lambda services. So I just wanted to give, how you can increase your knowledge on serverless on AWS, right? So you can contact your AWS account team to discuss more if you are interested to build a serverless application on AWS, or you want to move your existing legacy application to AWS in a serverless way. And if you want to know more about it, you can also contact us for conducting immersion day or workshops. And if you have some applications that are already in serverless architecture, then we can conduct well architected review. That's a var review for your applications. And we can also deep dive on many technical topics. You can visit serverlessland.com, take a note of it, where you can go through many solutions. Those solutions are implemented already in serverless way. Those are ready to deploy solutions, so you can go and explore. It is open to public, serverlessland.com, right? And again, you can continue your AWS serverless learning with your own pace. You can log on to AWS Skill Builder for more courses on AWS, and use our ramp up guides. We have a lot of AWS documentation and serverless documentation. If you just go to AWS websites. And you can also earn serverless badge if you want to showcase your knowledge on serverless. You can earn this digital badge, the serverless badge. So you can take note of this link or scan this QR code to go through courses, serverless learning courses, right? I'll just keep this slide open to you and I'll hand it over to Rohit for the demo. While he shares the screen, please feel free to unmute yourself and ask any questions you have. Thank you.
Thank you so much, Tejashree.
I'll just present my screen. Please let me know if you can see my screen. Yes.
Yeah,
Saketh,
I see the green screen.
Yeah, same here. I see the green screen.
not my application, right?
Oh,
No,
Okay.
no.
Okay. Yeah, let me just present my whole screen then. I think you can see my team screen now.
It's still the green one actually.
My screen's still green. Okay. Okay, let me just retry joining in the
Sure.
MS Teams. I think, yeah. Sorry for
yeah.
that.
So Rohit, I can present the screen. If there is a problem, just rejoin and try once. Yeah.
It's still the green screen.
Rohit, you're on mute, and we see green screen
Okay.
only.
Okay. So Teja, I'll just quickly share the PPT with you. Is that fine if we can present?
Yeah, sure.
Sure,
I'll
just give me.
present. So I'll open the one that I have already, right?
Yeah, no, I'll just share the updated one.
Okay.
Okay. Yeah.
Yeah, sorry for the glitch, but allow us for a minute, and I think we should be able to share the screen. So Rohit, are you sharing Slack?
Yeah, I have sent it on Slack. It's just uploading. Not sure why it's taking so long.
Interest of time, I'll share the one that I have, right?
Sure, that works.
Yeah.
Okay, it's sent actually.
Okay.
Teja, if you can just pull out the newer one. Yeah.
It is taking some time to download. So Rohit, I think it's taking a lot of time to download. Let me share the one. You can present the architecture, and I will give the link, and
Yeah.
then you
Yeah.
can
Okay.
send.
Sure.
Yeah.
Can you just
Yeah.
so yeah. So today I'll be, talking about a shoppable video, which is whose backend is completely built on serverless, right? And it's an event-driven architecture where, if there's any request that's originating from client application, right? Client, then basically it goes back to the backend, and based on that, our lambdas come to life, and the compute is provisioned for them, for their environment. It executes some code, and then finally it returns the response to the users. So this application, how it is like, it's like, let me talk about the use case. So the use case is like, let's say you are watching a movie in an application, right? Just like any OTT platform, right? And then you really liked an item in that movie or TV show that you are watching and you want to buy it. And now you want to know where you can actually purchase them, right? Or let's say you like the celebrity and you want to find more about them. Then yes, the solution will help you, take the snapshot of the frame that you're watching, or maybe the object or the celebrity is sitting in, then annotate that object with the help of the UI that's given, and you can send it for analyzing it. And this backend would get links to the e-commerce sites where you can actually purchase that product, or details about your favorite celebrity, or maybe any actor you were interested in. So maybe can we go to the next slide?
Yeah.
Okay. So yeah. So before the before we dive deep into the architecture, so so I'll just walk you through the key features, right? So the key features is like it enables users to buy items on e-commerce site, right? Then it also enables users to identify celebrities that are there in the frame. It also helps us in tracking user behavior, like the user that is actually watching the content, right, is interested more around this celebrity or maybe these kind of products, and then we could have a targeted segmentation of users in our backend, right? We can also recommend popular snapshots, right? We can keep on tracking that these snapshots were taken most, and like these were the more liked ones, and then we can recommend snapshots, because it may happen that they may like the people are actually liking the object, or maybe the person who's there in the stream, right? In the snapshotted frame. Then we can also recommend products endorsed by celebrities, right? So let's say once we have identified, like, based on that user behavior, we have identified that these users are more interested towards any person's movies, right? So what happens is, like, we can basically these users are interested in these actors, so we know that maybe they will be interested in the products that are endorsed by those actors, so we can recommend those products in shopping list, right? And of course the movie recommendation. So now coming to the architecture. So starting from front end. So we have a React.js web application hosted in AWS Amplify, which is a complete solution that lets you, easily build, ship, and host full stack applications with the flexibility to leverage the breadth of AWS services as your use case evolves, right? Or any new features coming. So we have this, static front end hosted on AWS Amplify, right? That's it. And all the no backend related stuffs are there in the Amplify. Then the application uses Amazon Cognito to add user sign up and sign in features and control access to the web application. So if I talk about Amazon Cognito, it provides a store, it's provide a user data store that scales to millions of users, supports social and enterprise identity federation, and offers advanced security features, to protect your consumers and business, built on open identity standards. Amazon Cognito supports various compliance regulations and integrates with front-end and back-end development resources, right? It's not just for the front-end applications. You can control your back-end resources as well. By maybe, okay, yeah. So all the contents related to the application, right? The videos, maybe, that is present in the OTT platform, right? Or even the snapshotted frame that is actually taken by the users and, which gets later used by Amazon recognition, and also by the app for rendering the snapshot in UI, is stored in Amazon S3. Amazon Simple Storage Service, that is Amazon S3, is an object storage service offering industry-leading scalability, data availability, security, and performance. It's highly durable, like it has 11 nines of durability. with cost-effective storage class and easy to use management features, you can optimize cost and organize data in S3. Then the application is again fronted with Amazon CloudFront, a content delivery network service built for high performance and security. CloudFront also helps us to deliver all the static content like images and videos used in the application to the users. So all the contents that are there, all the static contents, they get cached near to our end users where the application is being used. So it helps us in highly reducing the latency, right? So, and you also save some amount of cost when it comes to DTO charges, because anything that comes out of S3 via CloudFront, you pay a little less when it comes to DTO charges. We can go more than that, but yeah, let's just be focused on the architecture for now. So in the backend, now moving to backend, like we have all the things that are present in the front end now, and now going to the backend, what happens is our client application interacts with Amazon API gateway. So in the backend, Amazon API gateway is used to host REST API endpoints for serving the client requests with the help of AWS Lambda. API gateway helps us in creating, publishing, maintaining, and basically securing REST, HTTP, and WebSocket APIs at any scale. For this application, we are using REST API, but yeah, you can also go ahead with HTTP and WebSocket APIs for your own use cases. Right? API developers can create APIs that access AWS or any other backend sources. And as an API developer, you can create APIs for use in your own client application, or you can make your APIs that is available to actually third party people, right? Which and you can share that with them. So for serving the client request, API gateway invokes AWS Lambda. I think you are well aware with AWS Lambda now. So I'll just cut that short. So basically, you can trigger Lambda from over 200 plus AWS services and SaaS applications and pay only for what you use. So in here, what we are doing is our API gateway endpoints, the REST endpoints that we have in API gateway are backed by Lambda. So any request that comes from the client side, makes a request to the REST endpoint that is hosted on API gateway, and for serving that request, our API gateway invokes a Lambda function, and then Lambda function runs the code present in their function, and returns the response. So we have multiple Lambdas here, each helping in serving different kind of client requests. One Lambda function communicates with DynamoDB to store snapshot details. So Amazon DynamoDB is again a fully managed NoSQL database service, and it provides fast and predictable performance with seamless scalability. You can use Amazon DynamoDB to create a database table that can store and retrieve any amount of data and serve any level of request traffic. Now you may ask how, right? So Amazon DynamoDB automatically spreads the data and traffic for the table over a sufficient number of servers to handle the request capacity specified by the customer. So there are some certain request capacity, that is read capacity units and write capacity units, while creating the table that you specify based on your patterns of accessing a web application. The other Lambda function tells Amazon recognition for identifying the objects present in the annotated part of the snapshotted frames. So Amazon recognition offers you pre-trained models and customizable computer vision capabilities to extract information and insights from your images as well as videos, right? And that's what we are leveraging here. We are not building anything from the scratch. We're just using recognition's capability to identify celebrities and items from our snapshotted frames. Next Lambda function pulls out movie recommendations from AWS Personalize, which allows us to quickly build and deploy curated recommendations and intelligent user segmentations at scale using machine learning. Amazon Personalize picks up data we initially provided in Amazon S3. The data consists of data related to users, items, user item interactions, and then the recommendation gets user personalized as we feed personalize with the new data of our users interacting to different items in our web application. This again is done by one of the Lambda. Another Lambda function helps us in populating details about the different objects, with e-commerce links where we can actually purchase the things, right? Purchase the objects that were identified in the snapshotted frames, as well as the scalability details, right? That were given to us, in the snapshotted frame. So that's pretty much about the architecture. Maybe we'll just stop here for a while. If you have any questions related to the architecture, if you want to understand anything, please feel free to ask.
Hi, Doug. Thank you for the architecture you shared. I have a simple question. I have last time I have used same architecture for one of my projects, and I do not have any issue. But one of my project, I have not used the Lambda. I use the Amplify.
Yeah.
The Next.js. Next.js can handle the serverless
and
the backend
that's right.
and the front end same time. But I'm having issue when I run the Next.js. The server sleeping issue. This is the major problem I'm facing. Do you have any solution to the server sleeping issue?
So what's actually happening, we'll have to look deep into that, right? So if you could tell me more about the behavior, what's happening?
Yeah, like when I use the Amplify and same time when the Next.js API without the Lambda function. So once a user landing my site, the site is loading fine and smoothly. But if he stop working, like just watching my site, and after a certain time, like 1 minute or 2 minutes later, is clicking on an API. The API failed to call. It's because of the server is sleeping. And when again he refresh the page, like Control+Shift by using Windows computer, you have to refresh the page. Then once again the server is wake up and the running well. This is the issue. But the Next.js or React.js, we did not recommend to refresh and enter the site.
And that's very true. That's the whole point of using virtual DOM. So yeah.
All right. So this is my concern point. If you want, I can share a live example. So this is the biggest issue I'm facing. Even once I have moved to the the Vercel who built the Next.js. So I transfer one of my site to the Vercel hosting platform. I have not seen the same issue as on the AWS. So to be frankly speaking, one of my sites is called dronahost.com. It's still on AWS, even on the Amplify using and same time using your S3 services and the MongoDB. But I'm facing the same issue. Is the sleeping issue. Each server is going sleep like for the certain time, like 1 minute or 2 minutes. So this is the biggest problem. Like one of my author writing blogs, and he's writing. After 1 minute, when he click on the save button, the API failed to save it. It's because of server sleeping.
Yeah.
So this is the biggest issue.
Let me tell you one thing. Yeah. So actually, I've worked through multiple customers, that who actually leverage, Lambda. They also create runtime environments for their own languages that they use, customized runtime environments. I have not seen this kind of issue. What we can do is we can take this issue off the call and we can, dive more into it and help you resolve the problem. I think does that help? Right?
Yeah, it's okay. You can help me on another time. But I have read a lot of articles, to face this. But still today, I'm trying to find the genuine solution. If you support me on another time, that's okay. Not a problem.
Yeah. Surely, we'll connect with you.
Yeah, let's take your contact. So Saketh, would you help us to take his contact and we can get in touch with him later to deep dive?
Yes,
sure. Can I share my email address?
Yes.
Yes. The chat, and I think with interest of time, let's get it going with the flow we have, right? And thanks for bringing this up. I mean, that's a very interesting one, but thanks for bringing it up. right? Yeah, definitely. Our team will help you with this.
Okay, that's fine. Here's my email address, so you can contact me at any time. And if you share your email address so that I can contact, that will be fine for me. I can share my all of the details. That will be more better to communicate and fix the issue.
Sure.
Sure. We'll get in touch with you. Yes.
Yeah, I think you have a contact.
Thanks.
Yeah.
Yeah. Thanks, Thomas.
Yeah. Okay. So continuing, we'll just see the demo now. It's a live demo of our backend APIs in working in a full-fledged, and this our front-end application on Amplify. So yeah, we can just play. So this is a recorded demo which we will go through.
Rohit, I've given you the control. Can you check and see if you can play?
No, I'm not able to play. So you can just play the video. I'll walk them through it. That's fine.
Okay.
Yeah.
Oh shit.
I think you just need to click on the video once. I think you'll have to select that.
Okay, 1 second.
Yeah, that's right. You got one thing right.
Yeah.
Once you go to the video. Yeah, that's right. Yeah. So this is our, again, you see the CloudFront link on the top. It's totally hosted. So once you enter the credentials, you sign in, you have this home screen, It's fine. It's fine. You just, yeah, we can let it play. So you have the home screen, you have, that's getting paused. Okay. Yeah. So yeah, now you have different sections like home, movies, and then you have certain movies that's, getting recommended by AWS personalized and being pulled out from Lambda and being stored here. Now you're seeing this video, right? This Friends video. Now, what you are interested in is the couch that we are seeing in the movie. Let's say I want to really buy a similar couch. So I just took a snapshot of it. I got a response that it's taken. Then I moved to the review snapshots page where I have a bunch of filters, like if my snapshots are liked or not, liked based on the like. And then you can also filter out them based on the dates, as well as based on the text, the show name, right? So now what we'll do is we'll just move to the latest snapshot that we just took, right? So if I click on analyze, right, analyze tab, we have the UI for analyzing it, annotating it, and then we have celebrities merchandise tab, which are kind of empty. Now I click on annotate. What happens is I just create a box around the object that I'm really interested in. I save the annotated part, and now I have two options: either to get celebrities profile or suggest merchandise by, right, or by the objects. And I also like the object and send it for analyzing. Right. So analyze this. So analyzing is in process because my Lambda was invoked in the backend and it's still working on it. Right. Once it's ready, yeah, we got a response back from Lambda, right, and my snapshots are ready. So I see here, a bunch of things that were identified by recognition. That is cushion, home decor, interiors in pillow, couch, right? Now, let's say if I click on more details of cushion, right? I see here a bunch of items being populated and a link saying, this we can buy at Amazon, right? And yeah, as a user, you can just go there and buy. Right? Now, yeah. This again, same thing for couch, right? If I'm interested, I can just go ahead and buy. So yeah, if you click on view more, you will see more objects coming in, but they had confidence score of lesser than 80 to 85%, right? Lesser than 85%. That they are there in the picture by recognition. Now let's say I'm watching another song, right? See You Again. So let's say I'm watching this and now I come to a point where I am interested in one of the actor, right? So this is the actor. Now I actually took a snapshot of it. Now again, I go to review snapshots. I must be able to, see the latest snapshot that I just took. So it's the first time rendering. That's why the image came slowly. But yeah, next subsequent calls, it would be there cached in my CloudFront. So it will be faster. Now I annotate the actor I'm interested in. And I go for, get celebrities profile for me. I click on analyze. So once it will be ready, our lambdas go do the, process in the backend and return the response. I'll be able to, see that it's ready. Yeah, it's ready now. And then I have a bunch of details that, yeah, the actor was Paul Walker. And then this is a link to his, Wikidata, and then there's an IMDb link regarding the actor. So if I can go through those links and find out more about them, or I can just click on more details and read a few lines about him. And yeah, of course, these details are not, there's no end to these details. It's all to the point where you want to show how you want to show and which data you want to show to the end users, right? So that's pretty much. And now, yeah. So you can also delete the snapshots and definitely log out. So what we just saw here was, our static application just being hosted on Amplify and fronted with, a bunch of other services for authentication, and then distributed via CloudFront. And every click that was happening across the web application was kind of invoking our REST API in the backend, which was basically, backed by AWS Lambda. And AWS Lambda was, there was no compute running during that time before the, clicks or invocations. Now, after the clicks and invocations, what happens is there's an environment that gets provisioned for my AWS Lambda code that is there, right? The environment gets ready. It executes my code in the backend, and does all the work that's made that we make it to work, and, returns the response, right? And then the environment goes away again. Right? And you're only paying for the amount of the time your code was running in that environment. So that's how it was happening, right? So yeah, I think that's the whole beauty of, serverless, where, you only pay for what you use and you only use the servers only when required. So yeah, any questions here? So what we just saw was, serverless backend in action and one of the web application. Any questions, any queries, or, anywhere you are more interested in to listen about? Then we can just talk about this, right? This one solution, it has you'll have better user engagement, you are having some out of the box features of, annotating stuffs, bringing links to them so that they can buy the things. And if you are increasing user engagement, right, it will definitely help you bring down the churn rate. And then you have more option of monetizing via ads, you can put ads anywhere in the videos, right? And again, those ads could be also targeted, right, based on the celebrities or, the user behavior, right? As we have the track of all the user behavior. And then, yeah. So bringing down the churn rate definitely proposed to, increased revenue via e-commerce sales, right? So, yeah. And then better user experience with respect to contents, because we are providing user personalized contents across the platform, not just limited to the movies. I think, yeah. So that's pretty much about the demo. I think we can take questions and answers.
Yeah, thank you everyone for your time, and I hope you got the gist of how the serverless application can be built, right, using the event-driven architecture. So Rohit just demoed the architecture, that we demonstrated, where we build the web application completely serverless, right? Also using some of the AWS own services, such as recognition and personalize, so that way you're not spending more time on basic things of machine learning training or coding, but you're utilizing the features that are already available and focusing more on the business that you have, right?